Hello friends, myself Professor Ravindra Shinde, and let me answer you. And the question regarding this was uploaded earlier. It was regarding this Allene, and does this compound have dipole moment, and whether it will be optically active or not was the question. Now let us try to understand the geometry of this compound. The middle carbon is sp hybridized because it has formed two pi bonds, and the terminal two carbon atoms are sp2 hybridized. Sp2 hybridized carbon is planar. The three sp2 inner plane, the terminal carbon atoms are planar, and the one which is present in the middle is sp hybridized carbon, which is linear. So the hybrid orbitals of the middle sp hybridized carbon will make an angle of 180 degree, and the remaining two terminal sp2 hybridized carbon, they are in a planar, and the hybrid orbitals will make an angle of 120, 120, 120. Now the sp hybridized carbon on one side will form a pi bond with sp2 hybridized carbon on right hand side. Suppose that the two are in the plane of the paper, the pi bond pp parallel overlapping, and a sigma bond between sp hybrid orbital of the middle one and sp2 on the right hand side, and the second pi bond of this carbon on left hand side can be seen in this fashion. Now the first pi bond we imagine to be in the plane of the paper, then the second pp overlapping pi bond will be perpendicular to the paper. Now on paper this becomes complicated to understand, and for that I will use a model, wooden model, to explain this. Okay, now this wooden model which I have in my hands, these two are which are present between my fingers. These two are sp hybrid orbitals. This is the representation of sp hybridized carbon, sp, and this one is p and p. For the sake of simplicity, let this be 2py and this 2pz, sp hybridized carbon. This is a representation of sp2 hybridized carbon in a plane, sp2, sp2, sp2. These three are in a plane, and unhybridized p is perpendicular to these three, sp2, sp2, sp2. Now if this middle carbon, the sp hybrid orbital and sp2 will form a sigma bond, and pp will form a parallel bond. Now on this side, if I have taken the 3 sp2 inner plane, you can see on the other side. Now let me show. On the other side, this, the 3 sp2 to form a sigma bond cannot approach in this manner. They will approach in this manner, and the sp2 sigma bond and pz parallel overlapping. So this does not come in a plane. This does not become symmetrical. This becomes unsymmetrical, and the requirement for a substance or a compound to be optically active is absence of symmetry, asymmetric, or sometimes it is called as asymmetric. So on one side the plane is on the right hand side, I have shown in this manner, and on this side it is in plane. The 3 sp2 hybrid orbitals are in the plane, but the plane is different. The two planes are perpendicular to each other, and because of that this will not be symmetrical, and therefore ultimate dipole moment will be there. They will not compensate each other's effect, and the reason for a substance to be optically active, it cannot be symmetrical. This molecule cannot be symmetrical, and the groups are also different. So I think you have understood because I have explained in short. Thank you.